Hello there, my dear student. In today's lecture of class 10 physics, we're going to learn about light. Reference book referred for this chapter: NCERT Grade 10 Science, Physics by Lakshmi Singh and Manjeet Kaur, Living Science, Physics by Dhiren and Doshi, and some objective questions have been selected from question bank from cbsc.online website. Learning objectives. After the end of this lecture, student will be able to recall properties of light, reflection of light, types of reflection, and the characteristics of an image formed by a plane mirror. Suppose we enter a dark room. We cannot see anything even though we keep our eyes open. As soon as we switch on a bulb or a tube light, most of the objects in the dark room become visible to us. How do we see objects? For us to see any object, light must first enter our eyes. The sun, star, electric lamps, and candle all emit their own light. They are called as luminous source. However, most objects are non-luminous. For example, moon, planet, wood, table. We can see non-luminous object only because of the presence of daylight or any other light bounces off them. Light is a very complex phenomenon, but in many situations its behavior can be understood with a simple model based on ray diagram. In reality, we have a narrow beam of light which is made up of several rays. For the simplicity, in this chapter, we'll be using the term ray for a narrow beam of light. So, a ray of light is the direction of path followed by light emitted by a source. It is represented by a straight line with an arrowhead showing the direction in which it is traveling. Properties of light. Light is a form of energy and produces a sensation of vision. Light travels in a straight line. It does not need a medium to travel. That is, light can travel in vacuum also with a speed 3 into 10 raised to 8 meter per second. Nothing can travel faster than this. The speed of light seems to be a universal speed limit. Here the chapter can be divided into two parts: reflection and refraction. We will be dealing with reflection first. Reflection of light, the phenomena of bouncing back of light in the same medium after striking a surface, is called reflection of light. We will consider an analogy here. Imagine if we throw a tennis ball on a wall, the ball bounces back. This means that when the tennis ball strikes the wall sends it back. Similarly, when light falls on a smooth and highly polished surface such as mirror, or a shiny stainless steel surface, then it sends the light back. Now, the amount of light that is reflected depends on the material and the nature of the surface on which the light falls. Types of material: transparent object, translucent object, and opaque object. Difference between transparent, translucent, and opaque object. Materials through which things can be seen clearly are known as transparent. Example: glass, water. Materials through which things can be seen but not clearly are known as translucent. Example: butter paper, oily patch on paper. Materials through which things cannot be seen are known as opaque. Example: book, rock. In this section of Did You Know, we are going to learn something extra or something new.
Wait, why are you running so weird? What don't I know? My old nemesis, glass.
Birds can't see glass!
Yes, that's true. Birds can't see glasses. In reality, that is not so funny for birds, so I will also recommend to all of you to visit link 2 as well, which I will mention in the description box. Before stating law of reflection, we need to define some basic terms. Here, an M dash indicates a plane mirror. Light box, that is a source of light. AO indicates incident ray, that can be defined as the ray of light which falls on the mirror reflecting surface is called the incident ray. Point O is called as point of incidence, the point at which the incident ray strikes the reflecting surface of the mirror. OB is called as the reflected ray, the ray of light which is sent back by the mirror is called the reflected ray. ON is called as the normal. The normal is a line drawn at a right angle that is perpendicular to the mirror surface at the point of incidence. Here, angle I indicates angle of incidence, the angle which the incident ray makes with the normal at the point of incidence. Angle R indicates angle of reflection, the angle which the reflected ray makes with the normal at the point of incidence. Types of reflection. So there are two types of reflection. Regular reflection, also known as smooth reflection. Second type is diffuse reflection, also known as irregular reflection. Regular reflection, the phenomena due to which a parallel beam of light traveling through a certain medium on striking a smooth, highly polished surface such as a mirror bounces back from it as a parallel beam of light in some other direction is called regular reflection of light. Irregular reflection, the phenomena due to which a parallel beam of light traveling through a certain medium on striking a rough surface gets reflected in various directions in the same medium is called irregular reflection of light. As now we have understood the type of reflection, and as we have also understood the basic terms that are related to the reflection of light, let us state the law of reflection. So there are two laws of reflection. First, the angle of incident is equal to the angle of reflection. The incident ray, the reflected ray, and the normal all lie on the same plane. Now, laws of reflection are applicable to all types of reflecting surface. That means it is applicable for regular reflection as well as irregular reflection. Even in diffuse reflection, the laws of reflection are obeyed. The angle of incident and so the angle of reflection varies from point to point as the surface is not perfectly smooth. So the law of reflection are applicable to all types of reflecting surfaces. Here is a case study. What is the angle of reflection when a ray of light is incident normally on a plane mirror? Usually, in this type of question, students make mistake by taking r equals to 90 degree. With the help of ray diagram, we will try to answer this question. If you remember the definition for angle of incident, the definition which states that the angle which the incident ray makes with the normal at the point of incident is called the angle of incidence. So in this case, the angle made by the incident ray with the normal ray is 0 degree. Hence, the angle of incidence in such case will be equal to 0 degree. And according to the first law of reflection, angle I is equal to angle R, and hence angle of reflection is also equal to 0 degree. Here is another question for all of you. If in the question it is given that incident ray makes an angle of 30 degree with the plane mirror, find the angle of incidence and angle of reflection. Now, if you are thinking angle of incident is already given in the question which is equal to 30 degree, therefore angle of incident is equal to angle of reflection will be also be equal to 30 degree. In that case, your answer is incorrect. In such type of question, we need to be aware of keywords. So keyword in this question is incident ray makes an angle of 30 degree with the plane mirror, not with the normal. To solve this type of question, again I'm going to take help of ray diagram. Here, M and M dash is a plane mirror. Incident ray makes an angle 30 degree with a plane mirror. Let me draw normal as well. So as we know, normal is perpendicular to the plane mirror. So overall angle here will be equal to 90 degree, and the angle made by the incident ray with the mirror will be 30 degree. So this angle is given. So angle of incident plus the angle made by the incident ray with the plane mirror will be equal to 90 degree. 30 degree plus angle of incident will be equal to 90 degree. So the angle of incident will be equal to 60 degree. Check your understanding by solving some questions. Find the angle of incidence and angle of reflection from the diagram. Now this question is very similar to the previous one. If a ray hits a plane mirror at an angle of incidence of 35 degree, what is the angle between the incident and the reflected rays? So the keyword in this question is angle of incidence. Here is a pictorial representation of how images are formed in a plane mirror. Let us first list down what we observe in this picture. Object, which is a lamp, mirror, image, and an observer. Thousands of rays could have been drawn, but for simplicity, only two rays have been shown. Now, the light rays that are coming from an object incident on a plane mirror, after reflection, some of the rays enter the observer's eye. To the observer, it seems that the rays are coming from a position behind the mirror, where the image of the lamp is formed. Here, dotted lines have been drawn to show that the point where the two of the reflected rays appears to come from. And this is how image formation takes place. Now, you all must be wondering why suddenly a cricket scoreboard is displayed in this chapter that is also of year 2001. Let me assure you that after the end of this slide, you'll be learning at least two things. So this information I've taken from Wikipedia page. The Australian team, rated as the best in the world, had won 16 tests in a row, a test cricket record including the previous test at Wankhede Stadium in Mumbai by 10 wickets. So this was the second test match between India and Australia, and Australia went on to score 445 runs and India went on to score 171 runs. After the end of the first inning, India were forced for follow-on and went on to score 657 runs and built up a lead of 384 runs. With the help of Dravid and Lakshman, who batted the entire fourth day to build up this lead. India won the match by 171 runs after being forced to follow on. Only the third time this has happened since the Test cricket began in 1877. It is widely considered to be one of the greatest Test matches in cricket history. After the end of this series, VVS Lakshman was also referred as very special Lakshman. What we learn from this test series is that you should never ever give up, and the characteristics of an image formed by plane mirror. Let us see how we learn all these 6 points quickly. We will remember these mnemonics B, E, D, which represent bed, and from very special Lakshman, we will take these 3 letters V, S, L. So we need to remember these 6 letters B, E, D, V, S, L. Now we will see that what that 6 letter represent. So B, E, D here represent behind, erect, distance, while V, S, L represent virtual, same size, lateral inversion. So if we stand in front of the mirror, the image formed in a plane mirror is behind the mirror. The image in a plane mirror is erect or upright. The image formed in a plane mirror is at the same distance. The image formed in a plane mirror is virtual. The image formed in a plane mirror is of the same size as that of object. The image in a plane mirror is laterally inverted. Uses of plane mirrors. It is used in racing mirrors. It is used in periscope, which is used in a submarine to see ships over the surface of water in the sea, even though the submarine itself may be submerged underwater. It is used in kaleidoscope, which produces beautiful patterns that are used by fashion designers. It is used in solar cooker, which is a device that utilizes solar energy for cooking food. It consists of outer wooden box, glass sheet cover, cooking container with a food that to be cooked, and a plane mirror as a reflector. Check your progress by solving some questions. Do you know why the word ambulance on the hospital vans is written in the form of its mirror image? A letter which does not show lateral inversion when placed before a plane mirror is if an object is placed at a distance of 5 cm in front of a plane mirror, then calculate the total distance between the object and the image. man stands 10 meters in front of a large plane mirror. How far must he walk before he is 5 meters away from his image? That's it for today. If you have any doubt, you may post in the comment section. Until next time, stay indoors, stay safe. Thank you.